Good morning, I'm Dr. Huang. Today, I'm going to introduce 5 equations to calculate the heat or enthalpy change of physical processes. Equation 1, Equation 2, and Equation 3 can be used to calculate the heat of physical processes whenever there is only temperature change, but no phase change. This is Equation 1. Q equal to Cs times m times delta T. Q represents the heat. It has the same unit as energy, such as joule, kilojoule, calorie, kilocalorie, etc. Cs represents the specific heat. It is the heat required to raise the temperature of 1 gram of substance by 1 degree Celsius or 1 Kelvin. M represents the mass of the substance. The most commonly used unit for mass is gram. Delta T represents the temperature change. Delta T can be calculated by using the final temperature minus the initial temperature. The unit of delta T can be degrees Celsius or Kelvin. At this point, you may wonder, Dr. H, you told us the unit of heat, the unit of mass, and the unit of temperature change. You did not tell us the unit for specific heat. Now I'm going to teach you how to find the unit for specific heat by using the unit of heat, mass, and temperature change. Remember, we can use the skills from your algebraic classes to rearrange this equation. We will get Cs equal to Q over M and delta T. If we want to find the unit for Cs, specific heat, we can plug in the unit of heat and the unit of mass and the unit of temperature change. We will get the unit of the specific heat. We can also plug in the other unit for heat, mass, or temperature difference. This is also a unit for specific heat. But I want to remind you, the K here on top and the K at the bottom, they represent different things. The K on top represents kilo. The K at the bottom represents the temperature unit, Kelvin. This is the second equation. Q equal to Cm times N times delta T. The Q in equation 2 is the same as the Q in equation 1. It represents the heat. Cm represents the molar heat capacity. It is the heat required to raise the temperature of 1 mole of substance by 1 degree Celsius or 1 Kelvin. N represents the moles of the substance. Delta T in equation 2 is the same as the delta T in equation 1. It represents the temperature change. This is equation 3. Q equal to C times delta T. The Q in equation 3 is the same as the Q in equation 1 and equation 2. It represents the heat. C represents the heat capacity. It is the heat required to raise the temperature of a substance by 1 degree Celsius or 1 Kelvin. The delta T in equation 3 is the same as the delta T in equation 1 and the delta T in equation 2. Delta T represents the temperature difference. Equation 4 and equation 5 can be used to calculate the heat of physical processes whenever there is only phase change, but no temperature change. The Q in equation 4 and the Q in equation 5 are the same as the Q's in equation 1 to 3. The delta H in equation 4 and the delta H in equation 5 are the same. Delta H represents the enthalpy change of a phase transition. Delta H can be the heat of vaporization, the heat of fusion, the heat of freezing, the heat of sublimation, etc. The difference of the delta H in equation 4 and the delta H in equation 5 is the unit. The unit of delta H in equation 4 is kilojoule per mole. The unit of delta H in equation 5 is kilojoule per gram. Here represent the moles of the substance, and the gram represent the mass of the substance. Depends on what kind of delta H is given to you. You can choose either equation 4 or equation 5. Let me summarize the 5 equations to calculate the heat of physical processes. Equations 1 to 3 can only be used to calculate the heat of a physical process whenever there's no phase change, but only temperature change. Equation 4 and equation 5 can only be used to calculate the heat of physical processes whenever there's only phase change, but no temperature change. Equations 1 to 5 can only be used to calculate the heat of physical processes, but not chemical processes.